Right, in this video we're going to look at what is the law of cosines and then quickly look at how would we actually use it to solve problems in triangles and think about what type of triangles would we usually use it on. Okay, let's take a look. So the law of cosines can work in any triangle. It does not have to be a right triangle, and that's one of the main answers to when would you use this. Usually you wouldn't bother with this unless it wasn't a right triangle, although it does also work on right triangles. Now let's actually look at the formula. So let's label our vertices, the corners of our triangle, A, B, and C, using capital letters. And let's use lowercase letters for their opposite sides. Notice that the lowercase a is opposite from angle capital A. I'm going to put a lowercase b opposite from angle capital B. And I'm going to put a lowercase c opposite from angle capital C. The law of cosines formula would then state that c squared, that's a lowercase c, side length c, is equal to a squared plus b squared, and then some more stuff. But I'm going to stop here for a second. If you think about how to memorize this formula, that's the Pythagorean theorem. A squared plus b squared equals c squared. This formula is the Pythagorean theorem, and then minus some extra stuff. What is that stuff? 2ab cosine c. So if you just memorize Pythagorean theorem, a squared plus b squared equals c squared, minus 2ab cosine c, notice you have a nice ABC in there, just with a 2 in front and a cosine in front of the c. This is going to be pretty easy to memorize. Now you could write this formula with the a squared or the b squared in place of the c. What really matters here isn't what the labels are. It's that we have this c squared is the side length c, and the capital C is the only angle in this formula. Please notice that only one angle is used in this formula, and that is the other key detail to when will you use this formula. Step number one is it needs to be, you'd usually only use it if it's not a right triangle. And number two, you're usually going to use this if it is, if you only know one of the angles. That's usually when you would use this. And the key, again, is that these are opposites. That's the key to understanding this formula. Now let's actually look at an example. So what kind of problem should I make up to be used for the law of cosines? Well, I could make a triangle that is literally any triangle. It does not need to be a right triangle specifically. And again, I would usually do this in a problem where I know one of the angles. Let's say that we know that this is 35 degrees. Also, this formula is easiest when you're looking for the side that is across from the angle that you have. In this case, let's say that we're looking for this side. Now, to be able to solve using this formula, you're going to need to know the two sides that surround or create the angle that you know. Let's say that this one is 10, and let's say that this one is 20. Now, you could technically use this formula if you were looking for any of these four things I've filled in here. Any of them could be the variable, and you would need to know these have these four things as the type of information you have: the two sides surrounding an angle, the side opposite from the angle, and that angle. But this formula is easiest to use when it's this situation, when you're looking for the side across from that angle. Let's take a look. So in other words, we need to figure out what should we use. Well, our angle has to be the only angle we're going to use in the formula. And when we start out doing the formula, if you look at this up where is it there, that angle, that c squared, that has to be the side across from the angle. So what I'm looking at here is that this x is going to be like our c in the formula. So don't pay attention to A, B, and C as far as which one's on the left, which one's on the right, which one's on the top, which one's on the bottom. What matters is that your angle is paired up opposite with the one that you're going to use for C when you start filling in your formula. So we're going to go with x squared instead of c squared equals, well, for now I'm going to write down, well, okay, it would be a squared plus b squared, but what are a and b? Well, notice that a and b are just the other two sides. They're the two sides that aren't the one across from your angle. Also notice that they're linked with addition, and the only other place they show up, this minus 2ab cosine c, they're linked with multiplication. Well, the order of multiplication and the order of addition don't matter. You can rearrange them. That's the commutative property. And what that means is it doesn't matter in this formula which one is A and which one's B. It doesn't matter which one's 10 and which one's 20. It's just they are 10 and 20. It doesn't matter which one exactly is which. So what I'm going to do here is take all those spots in my formula and fill them in with 10 and with 20. And to make sure that we're still multiplying here, I'm going to use parentheses when we are doing that multiplication. Maybe we could highlight this real quick. So we've got the 10 and the 20 filled in our formula. And that's where they came from. I'm using the same color on both of them because, like I said, it doesn't matter which one's which. It's just the two that surround your angle. And again, the x and the angle here, the cosine c, wait a minute, we haven't filled in that part of our formula yet, remember? So remember that the angle that goes there has to be the angle that's across from whatever you put as your c squared, your thing by itself on the left-hand side of the equal sign. In this problem, that would be the 35-degree angle. Okay, so there we go. That is all filled in, and again, notice that these are opposites. You've got to make sure you filled that in correctly. That angle has to be opposite the side that you used on that side of the equation. Okay, now, how would you actually solve this thing? What if I told you that this is actually incredibly easy? X squared is now equal to, well, that right-hand side stuff, but here's the good news. That right-hand side stuff could literally all be typed in a calculator. If you have a scientific or graphing calculator, that allows you to type in a full line of text. You could literally type that entire thing in the calculator. How would you type that in? You would just literally type the entire thing in. You're going to go 10 squared, which just is 10 times 10, right? Then you would do plus 20 squared, which is 20 times 20, minus 2 times 10 times 20 times cosine 35, and you should get yourself an answer. So I'm doing that right now. 10 times 10 plus 20 times 20 minus 2 times 10 times 20 times cosine 35, and I get myself the answer 172. Well, it's like 339, and then there's some more stuff, but I'm just going to round it off about there. Now you'll notice that we're not quite finished yet here. We have x squared is equal to that. So how are we going to get just an x? Well, we're going to want to undo the square using a square root. Let me actually use a different color. So we're going to square root that. Okay? So we've got ourselves x is approximately equal, this one would have been approximately as well, to whatever the square root of 172.339 is. So I'm going to square root that. I can't type things out, guys. I pressed the wrong button. 172.339 gets us about 13.13. Okay, that is the easiest method for the law of cosines. It's when you're solving for that opposite side. At some other point, I'll make a video where I go into all the details of what if you were solving for one of the sides next to the angle, what if you were solving for the angle itself and you knew the side lengths. All of those details, like I said, look for in a future video. And I hope you guys have an excellent day. If you're interested in more math help videos, you can always think about liking, subscribing to the channel, that kind of thing.